All right, well, very good, Vincent. Thank you. Thank you so much. And I certainly appreciate ACI 364 and 222 for this opportunity. I believe we were actually supposed to do this last year, right? And part of the reason for the slight change in the title from 14 to 16 plus years, and it's really sort of a combination of things. If you consider when the mock-ups were done on this project, plus the fact that one of the towers was completed at the end of 03, the other one at the end of 04. So I guess technically we're looking at 16 plus years. And I actually do have some updates that I would not have been able to share last year. So just a little bit of background about the project. I'll share that first, and then the activities that took place in 2001, which was the investigation. And I like Pericles' tagline there, investigate before you rehabilitate, because it's kind of like trying to, if you're taking medication and you don't know why you're taking it because the doctor hasn't figured out what your issue is, it's kind of the same thing. But these projects, towers 1 and 4, were completed in 03 and 04. So that I'll talk some about that scope, and then give some updates in 2015 and 2020 on the project. So the project is located in downtown Boston, roughly in this location right here. And if just to get your bearings straight, to the east is Logan Airport, and to the northwest would be Harvard University. And this is an aerial view of those two towers 1 and 4. So I do want to acknowledge the team that was involved in this project. It was a really good team to work with, very collaborative, and I think as a result, I think they speak for themselves. So I do want to acknowledge the companies that were involved with this, what I think was a great project. So a little bit of background about the job. These are twin 38-story condominiums, again, located in downtown Boston. They were built in the 1970s, utilizing reinforced concrete. The project timeline for the job, and this was hence the reason for the title, a little bit of adjustment in the title, but the assessment was done in 2001. They did a mock-up toward the end of 2001. And what I liked about this approach was they actually built into the schedule to do a mock-up, and then they monitored it for a year before they finalized the specification and then went on to construction. And we don't always have that luxury, but it's really it's a great approach to first test out what you plan to do on 2 38-story buildings before you complete the job. The assessment, I think this ties in very nicely with what Pericles talked about. And I think really Simpson, Gumpertz, and Hager did an excellent job with the assessment, very comprehensive. They did a lot of sort of the standard tests that are typically done in reinforced concrete and repair. And really all of this was done in an effort to identify the problems, identify the extent of those problems, and to understand the root cause before really going on to specify the solution. And then the photos starting in the top left, testing for cover meter for the cover concrete and the reinforcing depth. In the middle photo is a half cell potential test. And in the bottom right is a core that was extracted and tested with phenolphthalein to determine pH levels and carbonation. So the problem after all that investigation was that really there were many locations that had spalled concrete, and it was due to steel corrosion. Here's an example of an underside of a slab near the window wall. You'll note significant spalling there, as well as staining on the wall itself to the left, where the reinforcement was close to the surface and corrosion was occurring there as well. Example here of a balcony undergoing some corrosion problems, and you can note there was a previous unsuccessful attempt to try to at least abate or to slow down some of the corrosion by simply painting the exposed reinforcing steel. That was not effective. Just sort of a stopgap attempt at trying to do something as the owner pondered what they were going to do. But a summary of the findings with all of that investigation was, that an investigation had been done in 1996. The owner elected not to do anything. In 2001, they did another inspection, and they saw that the spalling increased by 25%. The exposed column faces, balcony edges, floor slabs, they had the least amount of cover, and not surprisingly, they had the most amount of spalling. There were admixtures in the concrete, which was part of the source of the chlorides that were in the concrete. And this last bullet point, given the fact they had very low cover throughout, anywhere there was less than 2 inches of cover, there was active corrosion. So really just call your attention to these two items, right? In 5 years, the number of spalls increased 25%. So by the time they did the job in 2003, there were over 10,000 spalls between the two buildings, okay? And that number was just getting worse. So I think the owner realized they could not really put this off any longer. And again, this issue with the concrete cover and the active corrosion. So they had really corrosion throughout. So knowing this, the engineer had an idea of what they wanted to do, and they were considering obviously protective coatings and things like that. And they commenced with a mock-up. And as part of that mock-up, they picked two areas that were accessible, fairly easily accessible, and they did corrosion rate monitoring. So they embedded probes into the panels, and then they, in one panel, they applied just a coating, and on the other panel, they applied an inhibitor, a surface applied corrosion inhibitor, followed by a coating. And really, the engineer was trying to determine really what was maybe the best approach given the conditions on site. And as I indicated, they then monitored this for a year, so which I thought was very interesting. I haven't seen that done often, but it was a really good approach, I thought. They did the mock-ups in November of 2001. They monitored them for a year. The probes were monitored remotely, so they could gather data continuously throughout that 1 year period. And this is an example here. This is where the coating was used. And you can see a lot of erratic behavior in the corrosion. And just for relevance here, generally 2 microns per year, that would be considered low, which is this area here. If you're between, say, 2 to 5, that's kind of low. 5 to 10 is high, and then once you're above 10, that's very high. But these results just show really the erratic behavior of the coating really trying to cope with the corrosion. In the other area where they use the inhibitor plus the coating, you can actually see here that there is almost a fairly quick drop in the corrosion activity. Yes, some spiking initially, but over time that really began to sort of flatten out, didn't have so much of the erratic behavior. So the rates in this one actually started a little bit lower than where it was just coated, but they were reduced down to passive, and they remained at passive throughout the 1 year period. So based on this, the engineer felt that the combination of the inhibitor and the coating was really a good solution given the problems that they were combating. So that's a little background on the investigation and the scope development, the mock-up. Now we get into the actual project. That was completed, as I mentioned, in 2003. They completed one tower, and then the next tower was completed the following year, so by the end of 2004. So as I mentioned, the engineer finalized his scope based upon the mock-ups. And essentially on the walls, they used the inhibitor plus the coating. And on the balconies, they used a traffic membrane only. And they also plan to do corrosion rate monitoring in order to be able to assess the performance of the repairs, not just at the conclusion of the project, but going forward. And really, this approach was intended to target the widespread corrosion. You can see a number of products used in here to really specifically target the corrosion. And if I link that up with a document put out by the Building Research Establishment, very good scientists, they have this Digest 444, Corrosion of Steel and Concrete, and they break down into various principles and strategies of what the tools you basically have in your arsenal to try to cope with corrosion. And on this job, when I think about the specifications and the products that were used, they applied 5 of these principles to the job. They increased cover through the use of polymer modified materials and effective cover. They limited moisture ingress through the use of coatings. They used a surface applied corrosion inhibitor that was anodic. It was an anodic inhibitor as well as cathodic. And they used a rebar coating as well to, again, give effective cover to that steel, which a lot of it had insufficient cover that they were really trying to deal with. The sequence of the work, the contractor Spallane, they did a really nice job, I thought, of really coordinating the work. Very good work plan. They gave the engineer the opportunity then to really access the building and get their hands on 100% of the surface area as the project was commencing. They utilized mass climbers and swing stages to get access to the building. And they followed a very disciplined sequence of steps, which I thought was a great approach. So here's just a photo of some of the work in progress. You can see the mass climbers here in the foreground and the background, and some swing stage, again, to get access to the structure. In this case, they're actually applying the inhibitor, and you can see that by some of these areas that where the concrete is dampened with the initial application of the inhibitor, and then as it penetrates, and it does dry out over time. And then the protection side of the work involved the sealing, sealants, and the application of the coatings and the inhibitor, as well as the deck coating, painting of the handrails, and final inspection. So at the conclusion of the job, we now have our mock-up period. We have our specification finalization period and the completion of Tower 4. And then we have the completion of Tower 1. And these results I presented actually at ICRI it would have been in March of 2005. So at that point, we had about 5 months worth of data, and that's what this slide depicts. So you can see again here, this is one with the coating only. And you can see in this mock-up area that was done, but it continued to be erratic really throughout that, which is now over 3 years of monitoring. And those are really in that moderate range of corrosion activity. So a little concerning. And when you look at the other area of the mock-up with the inhibitor and the coating, you could see where it came down initially, and it really remained passive throughout that 3.5 year period. And I think really for the owner, the engineer, I think this was, confirmation that they made a good decision. You could see where it was just the coating. It seems that it was really struggling to try to mitigate that corrosion activity. And they went ahead and they installed these probes, not just in the mock-ups, but on floors 8, 13. So basically every 5th floor in one run in one of the buildings. And that was really a design decision of, how much monitoring are we going to do to try to, give us an indicator of how we think the repairs are performing. But what is interesting here is that the benchmark readings, over 50% of them were moderate to high corrosion activity. And within 5 months of completing the job, they have confirmation of data that shows good reduction in the corrosion activity. So really, it was a good indicator from the start that this was a successful approach. So again, here's the building in 2001, prior to repairs, and then in 2004, after building 1 was completed. And we're very proud of this job. It did win an ICRI Award of Excellence in the high-rise category in 2005. So we're really proud of that, and really a great testimony to the team and their effort. So now you fast forward 10 years to 2015. A few things have changed. There's now a new owner. They've renamed the building. It's the West End Apartments, no longer Longfellow Towers. But happily, they did agree to continue monitoring. And so we've been able to gather that data now. And I presented actually this to ICRI in 2015. So it was a 10-year update, basically, of the project. So here are some pictures from 2015, really showing both the buildings are in excellent condition. There was no reported spalls, no signs of distress, no rust staining. The coatings were not showing any sign of weathering. So really good performance. A little bit of a close-up of this is Tower 1. And even a closer up, more close-up view of Tower 1. And again, no signs of any staining, no rust, no spalls. So really good visual confirmation that it appears, we're getting really good durability out of these repairs. So again, back to this familiar condition before the repairs were initiated. And this is what the facade looks like now 10 years later. So visually, everything's looking really good. Okay. Some examples here of the low cover, the column covers where we had most of the corrosion activity and a lot of the spalls, as well as in the balconies. And again, here, this close-up of these column covers and the balconies look very good. But what really I think is unique about this job is not just visually, but now we have data that goes along with that. And these were the results of the baseline data. So this was prior to the repairs being initiated. And in this case, the red are high rates, right? So you've got, if it's above 10, so we've got 16, 25, 11, 13. So some pretty high corrosion activity. And then we have areas that are moderate in that 5 to 10. So basically, in the baseline readings, at least 7 of those are high, 9 of them are moderate, and only 2 of them are in a low state. 10 years later, we've now only got 1 location that's actually still a little bit high, and we have 2 that are in the moderate range, but all the other areas look good, and that's after 1 year. Then you fast forward here to year 10, and now we're basically down to 1 probe that's in the moderate range, which I think is really, it's a fantastic testimony of the performance of the repairs. You have the visual on the one hand, and you have the data on the other that confirms it. And if we go back to our mock-ups for that 10-year period, here's the one with just the coating. And you can see that at least for the first 5-6 years, it did seem to struggle trying to maintain those corrosion rates. But somewhere around year 6 or so, it eventually got to passive. And then if we look at the surface applied corrosion inhibitor plus the coating, really, again, very consistent throughout. This is when the project was finished, and then the monitoring over the 10 years, and it got down to passive, and it stayed consistently down there with really very little variation in corrosion rates, passive corrosion rates. And again, this is what the building looked like in 2015. This is one of the elevations. And we were very proud, once again, this building received an award of merit from ICRI in the longevity category, meaning that it had to be at least 10 years old, which it was at this point. So really very proud of that. And I would say, since we are a year later, if we had done this presentation last year, this would have been my final slide. But I've got some new information about the project. There were some recent inspections in 2020, and there is actually some planned repairs. And I did want to just touch on that in my remaining time. So at the 15-year point, they still look very good. And here is the data that I just showed earlier. And at 15 years, we now have a couple of areas that are moderate, but for the most part, very low corrosion activity. A report by the corrosion engineer that was recently supplied, looking at all of that corrosion data, and basically their conclusion was this is that point on the 35th floor. That area should maybe be looked at for potential reapplication of inhibitor or coating to provide some protection. But take a look at that. There is no spalling, there's no crack, there's no rusting. And that's the beauty of the monitoring, is it really allows you to intervene long before you start seeing those other signs. Okay, so I'm going to just quickly, on the assessment side, the facade looks really good. They do have some spalls in the balconies. So there is actually a project right now that they are beginning, which is basically they're going to wash the coating, reapply the coating, and just top it off. And they're going to do some repairs on these balconies, which also involves removing the handrails, which are embedded in the concrete. They're going to surface mount them, bring them up to code. So when you think about really where they were 17 years ago, and I think this is a great testimony of using embedded monitoring, which was innovative 20 years ago. And I think to some degree, it's still even innovative today. It's not used as much as I'd like to see it. Several materials were specified to address corrosion. There are materials, means, and methods to achieve durable repairs. A lot of times we're in the same boat. We're trying to convince the owner, right? And that's our challenge. So in a way, I'm preaching to the choir. But these techniques exist. Think system approach. There is no silver bullet. And I think really this is a great testimony of when you get a good team together, they work collaboratively. They're not trying to point fingers. We're trying to arrive at a solid solution and work together. They do an assessment, a mock-up, quality materials, good experienced contractor. There is QA, QC on site. Then they do monitoring. And all of that gives you 17 plus years of experience of performance. And again, keep in mind where they were in 2000, where they're at 10,000 spalls. It increased 25% in that 5 years. And here we are 17 years later, and there's virtually no spalling on this project. So with that, I know I'm out of time. But again, thank you, Vincent, for graciously letting me go over, I'm sure, a couple of minutes. And as well to ACI 364 and 222.